we will be discussing logic gates. Logic gates. Logic gates are the building blocks of digital circuit. Okay, these are the building block of digital circuit. That means all the computer, calculator, electronic devices, they are using logic gates in their core. Now, what is logic gate? Logic gate is an electronic circuit that operate with digital signal. Okay, digital signal or digital data. A digital signal is a signal which contains only two possible states. Suppose you have an analog signal. Suppose let us talk about the voice of mine itself. If you see the voltage variation, when I speak it out loud, voltage will be more like this. So you can see this kind of signal is called analog signal. Analog signal means a signal where the voltage or the current are continuously changing. This is an analog signal. Okay. But a digital signal can only have two possible values. Either say one value, let us say 5 volt, or another value say 0 volt, something like this. No other values possible in between. This kind of signals are called digital signal. A logic gate works with this kind of signal. Okay. So logic gate works with digital signal. Logic gate works with digital signal. A signal which have two discrete values. Okay, that's called digital signal. Okay. Now, a logic gate operates on a digital signal in a particular way. That means it will take the digital signal as an input and it will produce output based on certain logic. Okay, and those logics can there are three types of logic. Number one is NOT, number two is OR, and number three is AND. Okay, these are three kinds of logic gates that we have, and they will operate on the data in a certain way. For example, take the case of NOT. NOT, this is the symbol. This is a symbol for NOT gate. A is the input and the output we write as Y. And for NOT operation, the symbol is this. If you put a bar, no, that means you are taking a NOT operation. And what does it do is, suppose you are this is the inputs. Since this is digital data, only two values are possible. No? Digital data has only two possibilities. We denote these two possibilities as 0 or 1. 0 is one level, 1 is another level. And in case of NOT gate, you will get just inverted output. That means if it is 0, you are going to get 1 here. If it is 1, you are going to get 0 here. Like that. That's the operation of a NOT gate. Since it has inverted, no? It is also called inverter. It is inverter. That means it just inverts the input. Okay. And this is called truth table. Truth table means all possible inputs and corresponding output is called truth table. You can see here these are the possible inputs and these are the corresponding output. So this is called truth table. Okay. And this one, this y equal to this one, it is called the Boolean expression. Just like we have expressions like this now, ax square plus bx plus c equal to 0, some kind of mathematical expressions are there. In case of Boolean algebra, we have this kind of expression. Okay. That means this implies that you are trying to do a NOT operation. Okay. Now another interesting thing. Suppose you have an input A which can be 0 or 1 if you are doing an inversion. So let us take one more inversion. So when you put 0, you get 1. And this value when you again invert, you get 0. Similarly, if you put 1, this gets 0 and this will become again 1. So that means what? Double inversion is the same value itself. There is no particular gain by doing 2 times NOT operation. We will get back the earlier result only. Is this understood? Easy only, na? Okay. Now let us talk about OR operation. OR, the symbol is this. This is the symbol for OR logic. Sorry, OR logic. Okay. Here you have 2 inputs. See, this is one input, that is another input, and there will be only a single output. That output we denote by this. This plus means logical operation. OR operation is denoted by plus sign. It is not like our ordinary plus. It is not that ordinary plus. It is representing OR operation. Okay. So now let me write down the truth table. A, B, and Y is output. So when it is 0, this can be 0. When it is 0, this can be 1, like that. Keep one fixed, let the other change. Then you keep this same, and then once again let the other change, like that. So these are the possible inputs. You understand how it is getting? Keep A fixed, say 0, 0. A can have 0 or 1 only, no? Let it be 0, 0, and for 0, this you change it. Keeping this fixed, you change 0 and 1. Then you keep this again same, and then you change this. Now, according to OR logic, output is 0 only when both inputs are 0. That means you will get 0 here only if both of them are 0. So this is 0. Otherwise, if any one is 1 or both of them are 1, you are going to get 1, 1, like that. So you can easily remember this by remembering the concept of biology and maths. These are both 4th subject, no? Suppose some student is there who failed in bio also, maths also. 0, 0 in both cases. So he is going to fail. Suppose he has passed in bio but failed in maths. So he will pass. Similarly, he has passed in maths but failed in bio. So he is going to pass. If he passes in both, that is very good. He is anyhow pass. You can easily remember this logic by following this biology and maths thing. Okay? And lastly, we have AND operation. The symbol is, okay, I will try to write here, AND operation. It is given, this is the symbol, logic symbol, like this. There's a logic symbol. You have 2 input, A, B, and 1 output. And the logic expression is dot this time. Okay? Not plus, it's dot. And inputs, just like earlier, the truth table, you keep 0, 0, this can be 0, 1. Keep 1, 1, this can be 0, 1, like that. You understand this? Here, the output is 1 if and only if both the inputs are 1. That means this has to be 1, that has to be 1, then only output is 1. Otherwise, it is always 0. So 1, 1 is 1, otherwise it is always 0. Okay, that's the output of AND operation. Okay. So how can you remember this? Very easy. You just think about the practical and theory marks. Suppose some student fail in practical, fail in theory, he is going to fail. If he passes in any one of them, say theory of practical he passed, but theory he has failed, so he is going to fail. He has passed in practical but failed in theory, he failed. He has to pass in both theory as well as practical, then only he will pass. Okay, so that means output is 1 when both the inputs are 1. In case of OR, the output is 0 only when both the inputs are 0, otherwise 1. You should try to remember these exceptions. Okay, it will be easy for you to remember this way. Okay, these gates are called basic gates. These are called basic gates. So there are 3 basic gates: 1, NOT, OR, and AND. There are 2 other gates called universal gates. Okay, these are number 1, NON, and the other one is called NOR. No. These are called universal gates because you can get all these basic gates by using any one of them. Meaning is that suppose you have many NAND gates, you can combine them into NOT gate, or you can combine them into OR gate or AND gate like that. Suppose you have only NOR gate, you can combine them into get this all logic gates. That is why I call they are universal, because if you have them, you can have all this. Okay. So first we will discuss about NAND gate. NAND gate is AND gate. The result of AND gate, if you do an inversion, that is equivalent to NAND. The meaning is that AND is like this, no? That's your AND. Whatever result you are getting, A dot B, you are going to get. You invert this, ulta kar invert like this, A dot B with a bar. Then this is called your NAND gate. So NAND gate has two inputs and one output. So can you guess the truth table? Whatever is A dot B, that will just get inverted. So the truth table will be A B. Y is A dot B. Then you are going to invert it. So 0 0 0 1 1 0 1 1. These are the possible inputs. Output is going to be inverted version of this, and gets output is, you have to just invert it. So 1 1 1 0. So this is the exception here that you need to remember. You have to remember this way. In case of NAND gate, the output is 0 if both the inputs are 1. Okay. Once again, in case of OR gate, output is 0 if both the inputs are 0. In case of AND gate, output is 1 only if both the inputs are 1. In case of NAND gate, output is 0 if both the inputs are 1. Like this, you have to remember it. Okay? If you can remember this one, the other will follow. The opposite person will be there. Now let us talk about NOR. NOR is just like this. You have a OR plus NOT. So this is equivalent to NOR. OR symbol is this. Okay? NOT is this. This is equivalent to NOR gate like this. You have 1, 2 input and 1 output. So here if you give A, B, output is A plus B, no? And then you are inverting it. So A plus B with a bar you are going to get. So this result is A plus B with a bar. So can you guess the truth table? Truth table means this all possible inputs and all possible outputs. So you are going to do an inversion of A plus B. So what is OR? If you see the OR table there, no? You are going to get an inverted version of this. When this 0 0, you are going to get 1 like this. So in this case, this is the exception. When both the inputs are 0, output is 1 only in that case. Okay. So these are the 5 basic 5 gates that we need to learn. We have 3 basic gates. We have 2 universal gates. These are called universal because by using them we can get any of this basic gate logic. Okay? Yes or no?
Yes, sir.
You understood this? Okay. So now the last thing that we will try to do is how to get the basic gates from by using this NAND or not. This is what we are going to discuss. Okay. So let me use this space to explain this. It's very easy and interesting how we can get this. Okay, so for that we will need this table. This is for OR. This is OR, truth table. This is the truth table for OR. We will need that. Okay, so basically what we want to do, we want to have AND logic, we want to have NOT logic, and OR using NAND and NOR. Okay, using these 2 gates, how to get these 3 basic gates. Understood or not? These are universal gates. How we can get this gate, and this using them by combining them. That is our aim. Understood that? A? Okay. So you see, NOT has only one input, no? So what you can do is, this is the NAND gate, you can connect these two together. When you connect the two terminals together, if you give one here, one will be for both the inputs, right? Yes or no?
Yes.
If you give 0 here, 0 will be here also, here also. Now if you see the table for NAND gate table is this. If you give 0, both of them will be 0, 0 is 1. And when you give 1, both of them is 1, so you get 0. So that is your NOT gate using NAND gate. That means only you need to connect the terminals together. Okay, when you give 1, both of them are 1, result is 1, 1 is 0. When you give 0, 0, 0 is 1. Ulta ho gaya? Inverted, okay? Same thing with NOT. You need to connect these terminals together like this. So A inverted version you are going to get. You can cross check with this. That's your NOR, right? When you give 0, both of them are 0, result is 1. When you give 1, when you give 1, both of them, the result is 0. 1 is 1. Okay, is it understood? Once more, see. When you give 0, both of them, because they are connected together, both the input is going to be 0, 0. Output is going to be 1. When you give 1, both the inputs are connected together, 1, 1, result is 0, like that. Understood? So in order to get NOT gate, what we have to do? We have to just sort the terminals together. Okay, sort means connect them together. Now AND gate. So you have this AND gate, A dot B with a bar. We have learned that if you connect them together, no? But if you invert it again, the result is no use, right? Double inversion has no use, right? So whatever result you are getting after this, it's a NAND gate. A dot B, you are going to get A dot B with a bar. Again you invert it, so the double inversion will be there. And double inversion is same value only, so you are getting A dot B. So that's your AND operation. In a similar way, OR is also very easy. That's your NOR. NOR means A plus B, or with a inversion. You connect this with another inverter. That's the inverter. And you are going to get A plus B with double bar, and that is A plus B. Wow. This is an OR operation. By just doing double inversion. Is this understood? Huh? Yes? Okay. Now this OR and this part is same. See, in order to get OR using NAND, what you have to do? Use one AND gate, another AND gate like this. Put this thing here like that. Same thing with this. This is NOR gate. This is another NOR gate. Take the input or take the output and feed it to another NOR gate like this. That's your A, that's your B. This is your A dot B. It will work like this. I am going to explain how it is going to work. Okay. See, for this we will take help of this truth table. Let us say, what is the speciality about OR? Result is 0, 0 when both the inputs are 0. So let us give 0 here. 0, 0. This is an inverter, so you are going to get 1, 1. When it is 1, 1, what is the result of AND gate? 1, 1 is 0. So you see you are getting that. When both the inputs are 0, result is 0. Okay? Yes or no?
Yes.
Let us put 1 here. Let us see what happens. When this 1, this becomes 0. 1, 0 is, see the table? 1, 0 is 1. That means any 1 is 1, means you are going to get 1. That's your OR operation only. Okay? So this is how we can get OR gate using NAND gate. Now last point, this is the last one. Okay? So if you see, these are two NOR gates. Let us, what is the specialty about AND gate? AND gate is result is 1 if both the inputs are 1. So if I put 1 here, another 1 here, I get 0, 0 here because inverted output 1 1 give us 0. Now if you see NOR gate is this 1 1 gives you 0. So and 0 0 gives you 1. So when it is you are going to get 1. So this is what AND gate, no? AND gate में क्या होता है 1 1 से 1 मिल जाए. So you can get the basic gates from universal gates by using this combination. Yes? Okay. So any doubt you have? Okay. So actually what we have to study for example? Okay. We have to study the truth table. This is called truth table. We have to study the truth table for each and every gate. We have to study the symbol. We have to study the symbols. Okay. We have to study the symbols. Okay. And then we have to study